Welcome to the workshop. Today we want to take a look at section 5.2, spanning trees. Now in the last section, we already took a look at trees. And of course, back in chapter 4, we discussed graphs. And the idea of a spanning tree is that if we were to take a graph, a collection of vertices with a bunch of edges joining it. If we have a graph, what we can do is we can construct a tree on the same set of vertices using the edges that are already there. But what we can do is we construct a tree using edges from the graph on the same set of vertices. So again, it's the same collection of vertices, and then we just select some of the edges to create a tree, or we delete edges to make a tree. So let's take a look at the formal definition here, as well as a couple of examples that do exactly as I described, either include edges to build a tree or delete edges to create a tree. All right, so let's take a look at our notes. Okay, a spanning tree of a particular graph. So if we take a graph such as below, we can create a tree, right? So a spanning tree of a graph is a tree that's formed using the edges and vertices of G. But specifically, it does need to contain all the vertices of G. So let's take a look at one graph. These are the same graph. And what we want to do is we want to, in one case, select edges to build the tree. And in the other case, remove edges, so that way we're essentially removing cycles. All right. Yeah, we'll talk about the number of edges and everything in just a moment as well as we do this. So let's go ahead and select some edges. So what I'm going to do is I'm going to use a larger pen, kind of make it like a highlighter. Here we go. And I'm just going to pick a bunch of edges that create a tree. So I pick this edge. I'm going to pick this edge. Now, really, I'm just picking these arbitrarily, but the main thing is that you're just picking edges in such a way that you're not creating any cycles, and of course, you're not creating any new edges either. So here's a bunch. Let's see, I don't have this vertex in there yet, and I don't have this one in there either. So I'm going to go ahead and include this edge. There we are. And I'll go ahead and include this edge as well. And that gets us a tree, right? Because we have a collection of edges that create a connected graph in which there are no cycles. And it includes all of the vertices of the original graph. Excellent. So we can denote this tree simply by the edges, since the vertices are those of the original graph anyway. So T, a tree, is this particular set of edges. So we have B, F, G, and K. B, F, G, and K. Looks like I've also got A and J. Excellent. So let's go ahead and, so we've created one tree. Let's go ahead and create another one, but let's create it by deleting some edges instead of adding edges in. So we're going to delete edges to remove cycles. So these are maybe a little bit harder to see, but essentially we just want to start deleting edges because we already know that we have too many. So I'm going to go ahead and delete this one. Excellent. Now, how many edges should I end up with? How do I know that I have too many? Well, we know how many edges there should be because in the previous section we said, right, for properties of trees, if there are n vertices, there are n minus 1 edges. So here where we have, let's see, where we have 1, 2, 3, 4, 5, 6, 7 vertices, we should find 6 edges to connect them. 1, 2, 3, 4, 5, 6. That's exactly what we had in the first case. So I know that I need to get rid of some. So here, let's get rid of that one. Excellent. From there, let's see here. So that got rid of a cycle here with F, I, and K. Here there's a big cycle here. So we can get rid of that one by removing this edge, right? That's edge B, D, and G creates a cycle. So if I get rid of edge B, that removes that cycle. Now I also have a cycle with D, L, J, and C. So I'm going to get rid of D. Excellent. Let's see here. Do I have any other cycles? Yep, I see a J, L, A. Oops. Notice here I have 2 labelings. So I'm actually going to get rid of that labeling. So just call it H. But from this, I still have that cycle. So I'm going to go ahead and delete this edge. That gets rid of that cycle. And now the question is, do I have any more cycles? Let's see. Yes. Okay, this one's a little bit longer. If I travel along I, then F, then G, then A, then H, then J, I get back to where I started. So I have a cycle there as well. So I've got to remove one edge that was in there. Let's go ahead and remove edge F. I could have made a different choice and that would have been fine. There are many, many spanning trees for this graph. All right, can I find any more cycles? Well, now it's getting a little bit harder to see. So let's double check by adding up the number of edges that we actually have in the graph. If we have enough, or if we have few enough, then we should be good. So let's take a look at this. What ones do we have? If we have to delete some, that's fine. We can go ahead and delete them. But we've got A, C, G, I, J, H. That's 1, 2, 3, 4, 5, 6. Hey, 6 edges, 7 vertices. I know I have the correct number of edges. One thing that we should be aware of is whether we've disconnected the graph or not. But hey, according to the properties of graphs from the previous section, if we have 7 vertices, 6 edges, we have to have a connected graph, right? Assuming there's no cycles. We've presumably removed all the cycles, okay? Yeah, that looks good. All right, so again, A, C, G, I, J, H. A, C, G, I, J, H is our tree. Excellent. And if I wanted to make it a little bit more obvious that I went ahead and actually deleted all of these to get that idea here, I can change this color. Bam. Look at that. Select that guy and make that one white too. I've deleted edges. Excellent. So that's kind of fun. But that's how we can construct a tree, right? Now we have a tree that has the same collection of vertices as the graph did, and it uses edges from the graph, but it's a tree. And it's called a spanning tree. All right, there's one more video for this section that'll be posted shortly as well. So I'll see you guys back in the workshop in just a little while. Have a great day.